For decades, artificial general intelligence, or AGI, has been the ultimate holy grail in tech. You know, a machine that can think and learn like a human. But it's always felt more like science fiction than actual science, right? Well, what if I told you a new research paper just dropped, what might be the first real, practical blueprint for building one? Yep, it's a massive claim. Let's dig in and see if it holds up.
So before we get to the new solution, let's talk about the original problem. If you ask 10 different AI experts to define AGI, you're going to get 10 completely different answers. And that's been the fundamental issue holding the entire field back for years. I mean, think about it. How can you possibly build something if nobody can even agree on what it is?
For the longest time, AGI was something you'd debate in a philosophy class, not something you'd build in an engineering lab. It was all theory. But this new research basically says, okay, enough talk, it's time to move AGI out of the clouds and into a real, structured discipline. And in doing that, they might have just laid out the first truly concrete path forward.
To really understand why this new approach is so important, we have to first look at why all the old definitions, even from the biggest pioneers in the field, just fell flat when it came to actually building anything.
Okay, this table really tells the whole story. You see a clear pattern here, right? On one side, you've got thinkers like Ben Goertzel. He absolutely nailed the spirit of AI, focusing on how it should think, but he didn't give us any way to measure it. Then on the other side, you've got these beautiful, mathematically perfect ideas like AIXI, but they're literally uncomputable. You need more computing power than exists in the universe to run them. And then you have others like Miri, who were very correctly focused on safety, but they never actually defined the capabilities of the AGI they were trying to make safe. It's the same story every time. No concrete plan, no clear architecture, no way to build the darn thing.
So, to fix all of that, these researchers just went back to square one. They proposed a totally new definition, one that was designed from the very beginning to be practical, measurable, and most important of all, buildable.
And here it is. The key phrases here are everything. Autonomously acquiring new knowledge. That just means it learns on its own, without a human holding its hand the whole time. Transferring what it learns. That's the big one. It means it can connect ideas, like using something it learned in math to solve a logic puzzle. And then the killer phrase, modular cognitive architecture. This is huge. It means AGI isn't some giant, mysterious black box. It's a system of connected parts, each with a clear job. This isn't just defining what AGI is anymore. It's giving engineers a set of instructions.
So why is this such a game changer? Well, it's like they went through a checklist of all the old problems and fixed them one by one. It demands measurability, so we can actually test progress instead of just guessing. It demands a modular structure, so engineers know what they're supposed to build. It makes that cross-domain transfer a core, non-negotiable requirement. And maybe most critically, it bakes safety right into the definition from the start. It's not an optional feature you add on later.
And this brings us to the actual blueprint. See, the paper doesn't just stop with a new definition. It lays out a whole cognitive architecture, a detailed plan for how to actually structure an AGI's mind.
Let's walk through this, because it's pretty cool. It's a continuous loop. First, information comes in. The system then finds patterns and creates new ideas all by itself and stores them in its memory. Then it uses all that stored knowledge to reason through new problems. And here's the magic trick, step 5, transfer. It applies what it learned over here to solve a totally different problem over there. And finally, it learns from its mistakes and gets better. It's a complete, dynamic cycle of intelligence that just keeps running.
And this design tackles the single biggest fear people have about AI, safety. Instead of trying to bolt on a safety system at the end, this architecture has a safety alignment governance layer built right into its core. Think of it like a conscience. It's constantly checking the system's reasoning to make sure it stays on track and aligned with human values as it gets smarter. It's not an afterthought, it's fundamental.
Okay, all of this sounds incredible on paper. The blueprint is cool. The theory is solid. But the billion-dollar question is, does it actually work in the real world? Well, the researchers didn't just write the paper and call it a day. They actually built a prototype to prove this was more than just a thought experiment.
They called it QuickSAGI, and its whole purpose in life was to prove that this framework wasn't just another someday idea. The goal was to show, with a real working model, that their definition and their architecture could be built and validated right now with today's technology.
And the results were honestly shocking for a first attempt. That generalization score of 0.71, that means it solved more than 2/3 of problems it had never, ever seen before. The transfer score of 0.68 shows it was genuinely good at applying knowledge across different subjects. And crucially, look at that safety stability score.
0.96. That means the built-in safety system worked, keeping 96% of its outputs safe and aligned. That's incredible.
So when you take all those different scores, generalization, transfer, reasoning, safety, and you boil them all down into one single number, an overall AGI generality index, you get this, 0.77. Now, let's be clear, a perfect 1.0 would be some kind of godlike superintelligence. So for a very first prototype to hit 0.77, that is a remarkably strong signal that this framework is absolutely on the right track.
So, what's the big takeaway here? What does all this really mean? Well, this research could represent a fundamental shift for the entire field of artificial intelligence. What this paper really does is hand the keys to the kingdom to the entire AI community. It gives everyone a shared definition, a common blueprint, and standardized tests. It's a toolkit for moving AGI out of philosophical debates and squarely into the engineering lab. This allows for real, measurable, collaborative science to finally begin. So, we've got a definition we can test, we have a blueprint we can build from, and we have prototype results that show it's actually possible. Which really just leaves us with one pretty mind-blowing question. Is this the moment? Is this when AGI finally leaps off the drawing board and into the real world?